All right, it's very good to see everybody today as we are gonna do some adding and subtracting, some combining like terms. Gonna be good. We're gonna get after it today. Here's a quick review to make sure we're all speaking the same language about like terms. Like terms mean same base, same exponent. And the base is the thing that's like carrying the exponent, right? Like the base, and then you got the exponent. So this is the base and the exponent. So if the bases are the same and the exponents are the same, you can add them up. I got x to the fourth. I'm going to add another x to the fourth. Hell, I got 2x to the fourth. I'm rich. I got 2 of them. Now here, the bases are the same, but those variables aren't the same. 4 ain't the same as 2. And so if it's x to the fourth plus x squared, that's just equal to x to the fourth plus x squared. That's it. That's all you can do. So if someone's like, yo, what's x to the fourth plus x squared? You got to answer, it's x to the fourth plus x squared. You can't combine those. They already simplified. Down here, now the exponents are the same. Both of these bases are carrying the 4. They're both being multiplied by 4 times, themselves 4 times, but the bases are different, and so you can't add them, because you don't add those unless the bases are the same. So that's kind of our operating principle. Let's see how it applies to our problem over here. So what I do is I have the different like terms being color coordinated, so the blues are both going to be like terms. Same with the greens, because they are the constants. And we have that nice pink color there representing. So first thing is like perspective. Is this like you have this. That's how I see it. And you're going to take away 3 of those. 3 of these buckets, right? And so it's important for you to understand that you're not going to just take away 1 p to the 4th. Because you actually have 3 p to the 4ths. So first thing you're going to want to do is distribute this value. Now, usually, probably and you might eventually do it anyway, but a lot of teachers say you distribute the -3. But remember, that's a takeaway sign, and that's a +3. This says take away 3 of those. So what I'm going to do, and I like it because it almost in a sense makes me feel a little bit like I'm breaking a rule or something. I'm going to distribute a +3 because I'm going to take away 3 of these. You see what I did there? So what I really am going to have is pop quiz, hot shot. What color marker just fell? Answer, orange. All right, so I've got 3p to the 4ths plus I've got 2p squareds, but I got 3, sets of 2, so that's going to give me 6p squareds, or 2 times 3. Now I have plus, and I got my 3, so 3 times 3 is going to be 9. All right, there we go. I will bring this down. Great, so now we have options. You can go right to the answer at this point, or you can put your like terms together. So it's going to be kind of up to you what you'd like to do. But we could sit here right now and say, okay, I have 5p squareds, and I'm going to take away 6p squareds. Therefore, I'm going to have -1p squareds. Then you could say to yourself, okay, I'm going to take away 9. This is where this method, it might be helpful for you. Sometimes it's to, instead of using take away positives, go plus and then make it negatives. So you have -9, right? So -9, you're going to take away 9. So -9 take away 9 is going to be -18. So you got plus -18. And then we're going to see how many of these p to the fourths we have. So I have 7, and I'm going to take away 3, which is going to leave me with 4 p to the fourths. Now the last thing you probably want to do is put this thing into standard form, which says the largest exponent has got to come first because it's thought of as the most important, or it affects the equation the most, so we want it in the lead. So what I'm going to do is I'm going to switch this so the exponent of 4 comes first. I'm talking about that right there. Then I'm going to bring in the next biggest exponent, which here is p squared. I got the 2 up there. And then lastly, you have the 18, which is the smallest exponent, which you could say is p to the 0 because anything to the 0 is 1. But I'm not going to do that. And then lastly, mathematics, we don't usually do plus negatives. You just rewrite everything as a subtraction. So it looks like that. And I already used my green. I normally circle the answer with green. Now I'll circle the answer with orange. And voila! There we have it. Very nicely done. Let me show you one more way of going about this. Okay, so let me erase what we've got here. And what you can do is you can distribute a -3 right off the top, but I want you to keep in mind that when you distribute a -3, really you're saying this. You're saying that this is going to be plus -3. And now you can distribute that, and you keep a plus sign. And so now it's a negative. Right? And now this is a negative here. And this would also be a negative here. And you notice you're going to get the same answer because you're going to get 7 plus -3 is 4. All right? So it's up to you however you want to do it. Some teachers do tell you that once you don't have a number outside of a parenthesis, then you actually don't need the parenthesis. It's not doing anything for you. And so you can get rid of these. Okay, you could do that. And then a lot of times teachers will say, okay, and then group the like terms together. So it's an extra step, but it can be helpful. Certainly can be helpful. So let's just do that, just so you get a sense of what it would look like. Okay, so then you get 5p squared negative 6p squared, okay? And then what we're going to have the minus 9 and minus 9. And then I'm adding, right, of all addition, right? Everything here I did as a plus. And you can see you'll go down, you'll get that same answer of -1. So you get 4 minus 1, p, 1 is mine, p squared, minus 18. All right, let's try one more. Brilliant! All right, well, let's get this rolling here. First thing I would probably want you to look at is notice where your like terms are going to be. So for instance, if I switch the color here, okay, so when you switch the color, you can see when I'm finally done, I'm never going to combine terms that aren't going to be the same color or they're not the same like terms. And so our final answer, if you look at it, these are the only two where we're going to have to do an actual combining, right? We're going to get a step like this over here. So let's see what we're looking at. So we have 5x to the 6th minus 2x squared, or just showing plus -2x squared, plus 1. Now here, that means we're going to take away 4x to the 3rd plus 40x squared, and I just switched to all black there. So now let's do the subtraction. So you can go 5x to the 6th plus, and let's move to the next term. Now, we don't even have an x to the third over here. So when that happens, one thing you can do, you don't have to do, and I guess you got 5x to the 6, you can go like this. So let's go 5x to the 6th, and you can go plus 0x to the third. If it helps, you don't have to do it, you can just know it's there, but so now in your head you can go 0 minus 4, right? So you could go 0x to the third minus, and you have 4 of those, so that's going to give you negative 4, so you get negative 4x to the third plus, okay, let's go to the squared term, so minus 2x squared, take away 40x squared, so we're going to be at minus 42, so you get minus 42x squared, because you get minus 2, take away positive 40, and anytime you take away a positive, you get more negative. That's true in your life. Anytime you take away positivity, your life gets more negative. So let's keep all that positivity. And now I got 1 minus, there's no constants over here. And so I still just have the 1. I'm taking away, or, like I said before, you can put placeholders if that's helpful. Really, it means it's plus 0. And then 4 times 0 is 0. And so 1 minus 0 is going to be 1. And there you go. And again, your final answer, you should go back and just, instead of writing plus negative, you can go back and do this. And it's all good in the hood. Let's use orange. Oh my gosh, thank you very much. That's very, very beautiful. All right, well, I think that's pretty good. I think the only other point I want to make is if we go all the way back to here, is you can distribute a negative 4 right away, right? So you can do this. It's fine. It's nothing wrong. You don't have to write plus negative like I was doing earlier. But it's important that if you do distribute the negative, to just remember that that's really what you're doing. You're really saying instead of subtracting 4 of these, you're going to add negative 4 of these. Because really that plus sign should come down, and you get negative 4 times x to the third, which is negative 4x to the third. And of course, plus a negative means minus. Okay, and so you can hold it like that as well. That's totally legit. You can look here. Whoops, that's a 40. Human mistakes. And you could say, okay, I'm going to take away 2. I'm going to take away 40. That means I'm going to take away 42. And then just for completeness sake, you could go like this as well. You should rearrange things, right? So you want that higher one coming first. Take away 2, take away 40. Okay. Okay. So it's really up to you. I want you to understand what you're doing. That's the most important thing. Negatives can cause a lot of issues. And in my life, I've figured out that if you treat that as a subtraction sign, that's the way to roll. It's really important. So that's minus a positive. If you want that to be a negative number, then remember that's what you're doing, right? You're now adding a negative. Hey, good luck. Take care. It's a sunny day, I can see, so I hope it's sunny where you're at. And yeah.